In this video, we're going to solve two exponential equations. Now, ideally, we're going to be able to find a common base for both the left and the right sides of the equation. So let's see if we can do that. In this first example, we have bases of 16 and 8. And if we take the time to think, these guys do have a common base, and they have a common base of 2. And if you ever forget that they have a common base, think about what 8 is made up of in terms of all of the same factor. So 8 is made up of 3 factors of 2. So we know that 2 to the third is 8. So we're trying to figure out how 16 works into that. You can just kind of build your way to that. So if I multiply times another factor of 2, that would give me 2 to the fourth. Well, that just gives me 16 because 8 times 2 is 16. So that means that we can rewrite each side as something that has a base of 2. So 16 gets rewritten as 2 to the fourth raised to the 5x power, and 8 gets rewritten as 2 to the third raised to the 3x minus 19th power. And as we have seen previously, when you have powers to powers, these are going to multiply. And so we now have 2 raised to the 20x equals 2 raised to the 9x minus 57. Make sure that this power of 3 distributes to the other power up there. And now, since these guys, since these guys have the same base, so having the same base means that we can now equate their powers. So it means we now have the equation 20x equals 9x minus 57. So you get each side to have the same base. And if you got powers to powers, you're going to multiply those guys. And now that you have the same base, that means that these powers are equal, and this is your equation. And it's a nice linear equation for us to solve. So to solve this, we're just going to subtract 9x. And we have 11x equals negative 57. Don't forget there's a negative connected to that. And then we divide both sides by the coefficient. And x equals negative 57 over 11. You can try to simplify this if you want to, but it's just not going to happen. Now what we can do is that we can go to our graphing calculator and check to make sure that what we have is correct. So real quickly, let's take this guy. This is negative 57 over 11. We're going to store this into x. And we get this decimal. Okay. Now let's see if both the left side and the right side will give us the same value whenever I type them out. So 16 raised to the, make sure you use parentheses here, and do 5x, and I get a crazy small number, 6.3 times 10 to the negative 32nd. Okay. Well, let's do the same thing over here. Let's do 8 raised to the parentheses 3x minus 19. And you see that I get the exact same value, right? So we know that negative 57 over 11 is correct. So it's a nice, simple way to check. You store it into x, and then you type in each side of the equation to see if you get the same value. All right, and our next example. Here in this next example, we have 1 over 36 to the 4 minus x is equal to the 9th root of 6. Now, when you're trying to identify a common base for both sides, ignore the fact that you have a fraction and ignore the fact that you have a radical. Look at the bases here. Look at the 36 and look at the 6. Do they have a common base? And the answer is yes. They're both based off of 6, right? This is 6 to the first, and 36 is 6 squared. So we're going to use that information to try to rewrite each side of the equation. So instead of saying 1 over 36, I'm going to say 6 to a power. Now here's the thing. If I just had 36, you would say 6 squared. But since it's in the denominator, that means it's a negative power. So we're going to say 6 to the negative second. And this is raised to the 4 minus x. On the other side, well, inside there, that's just 6 to the first. But when we have an index, we've talked about how these radicals connect with rational exponents. So this index of 9 corresponds to a denominator of the power of 9. And so we're almost there. We've got both sides written in terms of a base of 6. On the left side, you have a power to a power, so we need to multiply. So 6 to the negative 8, and then plus 2x, equals 6 to the 1/9. Please make sure that you understand that you are never going to take this base and multiply it times the power. That's not how it works. You're trying to get each side of the equation to have the same base, because if you have the same base, you can now equate their powers, which gives us the equation negative 8 plus 2x equals 1/9. Now, if you don't want to mess with fractions, and I know most of you probably don't, let's go ahead and clear out the fractions. You identify the common denominator for both sides, which is 9, and we can multiply both the left and the right sides of the equation times 9. This is not raising to a power, we're just multiplying times 9. So this gives me negative 72 plus 18x equals, and over here, these 9's reduce away, and I just get 1. And so again, you have a nice linear equation to solve. You need to get x by itself. So you're going to add 72 to both sides. And we have 18x is equal to 73. And one final step, and that's just to divide both sides by 18. X is equal to 73 over 18. Now, 73 is prime, so that means there's no way we're going to be able to reduce this fraction. So this is my answer. All right. Now, let's go back to the graphing calculator. Let's check to see if what we have is correct. Okay. So, let's take this 73 divided by 18 and throw that into x. And now let's check this out. So this is parentheses 1 over 36, and then raised to the, now since you've got more than just a single piece here, use parentheses 4 minus x. Alright, so it's a decimal. That is really not that important to me. What I now need to do is to see if that decimal is the same thing as the 9th root of 6. So it's kind of tough sometimes to type in the 9th root, so I think it's really best if we look at this as a rational power. So this is 6 raised to the 1 divided by 9th power, just like I wrote here. So there's no variable involved, I'm just kind of rewriting that expression, and you see that yes, I do get the exact same value, so everything checks out.